Good morning, all of you. So, in today's class, we are going to learn degrees of freedom. Degrees of freedom. So, first of all, what is this degrees of freedom? So, I am writing here definition. The number of possible ways the number of possible ways in which a system can possess internal energy. Okay, what is degrees of freedom? The number of possible ways in which system can possess internal energy. This is what definition of this degrees of freedom. Now, how many degrees of freedoms are there? So first one is translational. So I'm writing here what is translational degrees of freedom, vibrational degrees of freedom, and rotational degrees of freedom. So first, generally we will discuss first about this translational, rotational, and vibrational degrees of freedom. So first one is translational. First one is translational. Second one is rotational, and third one is vibrational. Translational, rotational, and vibrational. So translation means the motion along x, y, and z axis. So maximum can be 3. Maximum can be 3. That is half m phi x square, comma half m phi y square, comma half m phi z square. Okay, this is what translational degrees of freedom. Next one, rotational degrees of freedom. This is also maximum can be 3 only. So these is because of rotation. So that's why half ix omega x whole square, half iy omega y square, half iz omega z square. This is not rotational kinetic energy, we can say rotational internal energy or rotational degrees of freedom. Next here, vibrational. So this vibrational degrees of freedom means when molecules are getting vibrated, whatever the energy is getting possessed, that is what because of this vibrational degrees of freedom, or that is coming under this degrees of freedom. So see here, their numbers depend on their number depends on atoms in the molecules, atoms in the molecules, and their arrangement. And their arrangement. Okay. And these degree of freedom, DOF means degree of freedom, considered at high temperature. Why at high temperature? Because at high temperature vibrations are possible. Considered at high temperature. Okay. Considered at high temperature only. Which one that is? Vibrational degrees of freedom. So let's learn in detail. You will ask me a question at what temperature. So this is at room temperature we can consider. At room temperature only these two. At high temperature only this. Keep it in mind. Okay. Understood? Yes, note down. Okay, next. Now let's learn in detail. The first one is monoatomic gas. Monoatomic gas. Okay. So in this degree of freedom is due to three independent translational motion. Three independent translational motions, that is along x comma y and z axis. Okay, so already I told. So for example, let's take one monoatomic gas, for example neon. Yes. Next one is helium. Yes, argon. All these having only one atom in a molecule. So if suppose this is x, y and z axis, then there will be only three translational motions along this particular axis. Can you see here? Yes. So these are the three axes, x, y and z. So this is x, this one is y, this one is z. So along x-axis it is having velocity vx, along y-axis it may have velocity vy, and along this axis it may have velocity vz. So here degrees of freedom will be what? For this DOF will be 3 and all are translational. Only they can perform translatory motion. So degree of freedom is 3 for monoatomic gas and all are translational. Understood? Okay, next one. Next one is diatomic or polyatomic. Next one. Second one is diatomic. Diatomic or linear polyatomic gas. So this type of gases will have three translational plus two rotational degrees of freedom. Three translational plus two rotational degrees of freedom. How? I am drawing here one diagram. You can see this is diatomic or polyatomic. It means there are more than one atom in the molecule. So you can see here. So this is a molecule here. This is a diatomic molecule. Now you see this is rotating about this axis. So here this is Z, this one is X, and this one is Y. So here Ix is equal to Iy, which is not equal to 0. But here Iz will be equal to 0 because it is moving along that axis only. So about these two axes you will have moment of inertia. So three translational means you will have energy like this: half m vx square, comma half m vy square, comma half m vz square. Whereas you will have only two rotational degrees of freedom, that is half Ix omega x whole square, comma half Iy omega y whole square. This is for diatomic gas. And note point here, or example I am taking, first of all, example of this diatomic or polyatomic gas is, you can take anything, for example, hydrogen, nitrogen, okay, oxygen, etc. Note point here, note point, in case of this diatomic or polyatomic or linear polyatomic gas, if if or at higher temperatures, direct I am writing, at higher temperatures, at higher temperatures, up to, without higher temperature, how many degree of freedom? So total degrees of freedom here is equal to 5. And if at higher temperature is considered, then at higher temperatures this diatomic gas has 7 degree of freedom. How 7 of degree of freedom? Because one you are getting half mu v square because of kinetic energy, corresponds to kinetic energy, and half k r square is corresponds to potential energy of vibration. Now you will ask me, sir, above also you are getting kinetic energy, below also you are getting kinetic energy, then what is the difference? Now see, these two energies, this is because of vibration. Keep it in mind. Vibrational energies. Vibrational energies. कौन से ये दोनों, this and this also. This is already you are having. So this 3 plus 2, 5. But here you are having how many degrees of freedom? We can see. This 2 you are getting extra. So here, therefore, at higher temperatures, therefore, at higher temperatures, degree of freedom is how much here? 7. And that is how you can see, that is half m px square comma half m py square comma half m pz square. Then this 2 rotational half ix omega x square comma half iy omega y square comma these two again, that is half mu v square and half k r square. But sir, what is this mu and this k? Okay, this k and r and all these things, what is this? Will you please tell? Yes, so this already you know, half m vx square means this is velocity, this is I is moment of inertia. So I'm writing here, you just keep it in mind in this box. I is moment of inertia. I is what? Moment of inertia. Omega is angular velocity. Angular velocity. And mu. Mu is what? Reduced mass, we can say. Mu is reduced mass. Mu is reduced mass due to vibration, we can say. This k is force constant. And this r, which is coming because of this vibration, that r is the separation between the atoms. Separation between the atoms, right? This is what degrees of freedom for diatomic gases. So when you have to use 7 and when you have to use 5, that you have to see carefully. Okay, at high temperatures you are getting one extra degree or 2 extra degree of freedom, that is vibrational degrees of freedom, and that is half mu v square and half k r square, right? Understood? Okay, so let's move ahead. Next one, that is triatomic or non-linear polyatomic gas. Third one, triatomic or non-linear polyatomic or non-linear polyatomic gas. So in this type of molecules, you are having total 3 translational and 3 rotational. Initially, you will have 3 translational and also you will have 3 rotational, 3 translational degrees of freedom plus 3 rotational degrees of freedom. And if so, total degrees of freedom is how much here? Degrees of freedom will be 6. If vibrational energies are considered, or just you can write like this, at higher temperature, है ना? Because vibrational energies are possible when only at high temperature. So if suppose you are having, if I'm writing like this, if at higher temp or if such a molecules will have, if such a molecules has free vibrational modes, it will have 2V vibrational degrees of freedom. So that is degrees of freedom will become 6 plus this 2V, additional 2V, and V is what here? Vibrational modes. V is what? Vibrational modes. V is what? Vibrational modes. How many vibrational modes are there? If one vibrational mode is there, means degrees of freedom extra is how many? 2. Keep it in mind. Right? So I'm drawing the diagram, or even we can take the example of such type of molecules which are having triatomic gas, or the gases which are made up of this type of, or gas which one is made by combination of 3 atoms, we can say. So here it is H2. Okay, next one is what? SO2 etc. If we will draw the diagram of this type of gases, suppose this is x-axis, this one is y-axis, and here is z-axis. like this. This one is X, this one is Y, and this one is Z. This is what triatomic gas is. So these node points are very, very important when vibrational energies are considered, particularly in first, second, and third cases. But only you are having in two cases these node points. Keep it in mind. Okay, which will increase your vibrational modes or just energies also. Right? So note down this. I am going to give you one chart so that how to keep it in mind. Let's see. So see here, degrees of freedom of different gases at room temperature as well as, but better we'll keep it in mind for the, what you can say at room temperature only. At higher temperatures already I have given. So at room temperatures I am giving here at room temperature, only at temperature. First one, that is atomicity of gas. Next one is example. Next is figure. And next one is degree of freedom. That is DOEF. So we have seen three types of gases. So you can make three columns or three rows. So first one, that is monoatomic. Example is what? Helium, neon, argon. And this diagram is what? Just a translatory motion, that's a dot. Degree of freedom, how many? Three, and all are translational. Only they can move along each axis, that is translationary motion only. Okay, three translation. Next one is diatomic or linear polyatomic. Second one is diatomic or linear polyatomic. So example is what here? H2, N2, O2, next CO, comma CO2, CO1 and CO2. So its diagram is how, like this, and it has three translational plus two rotational, total equal to 5. Third one is triatomic or non-linear polyatomic. Or non-linear polyatomic gas. So its example are what? H2O, SO3, SO2. And this diagram you know already. It is like this. So here you are having three translational plus three rotational, and total how many degrees of freedom? 6. Got it? And at higher temperature, if you want, here you will get extra 2, and here it is extra 2V. So if you will add one column here at high temperature, at high temperature, this is plus 2, that is vibrational, and here it is plus 2V, where V is modes of, where V is what? Modes of vibration. You know, V is what here? Vibrational modes, right? If you want, you can keep it here only like this, extended one. This is for this one, and this is for this. Okay. For this, it is not there. For monoatomic gas, there is no vibrational energy. Okay. So this you keep it in mind. Got it? This is what degrees of freedom for particular molecules: diatomic, triatomic, and polyatomic. Note down properly and carefully you read once. Okay. So let's stop here for today.